So let's look through the 2021 paper. I've started doing this now, I didn't do this before, but I would skim through your paper and have a look at the questions, and maybe just to get your confidence up, you might decide to do in a slightly different order, I don't know, just to do ones that you like. So, if we look at question one here, clearly it's a quadratics question, find the roots, sketch. Here, f dash, we're looking at a differential, that's quite a nice easy one. And I'd say these are probably the easiest of all, where you've got your, move this over, you've got your inverse to rearrange, quite a nice one too. So, you might go into the exam and just flick through, settle yourself down. There's a straight line question, pretty easy. You've got your addition formulae, again, not too bad. More functions, looks a wee bit complicated. I'll complete the square at the end, but basically functions substituting in, again, quite a nice one to get you going. Composite integration, so you're looking at your formula at the front of the sheet. Again, straight line question. Between two curves, so we're integrating, so maybe a bit more working involved in the integration. You've got to be careful not make a silly mistake, so maybe I'd leave that to the end. Factorise fully polynomials, maybe I would do that first because synthetic division is not too bad. And very finally, a bit of a problem solving question, I'd probably leave that more towards the end as well. So, whatever works for you. As you see, there's got a lot of straight line questions in there. There were some polynomials, some quadratics. So yeah, not any logs in this paper, which is a bit of a shame. I do like the log question, so if you've studied for logs, that's nothing for you in this paper, unfortunately. But what there was quite a lot of straight line questions, and the other paper had a lot of differentiations. The Calc's got a lot of differentiation. So yeah, look, just whoever works for you. But you might want to just settle yourself down, go through, have a wee think, and pick off those marks you definitely know, synthetic division, straight line, stuff like that. Okay, but I'll just work through it obviously in turn, and just so you know, it's a strategy. Anyway, find the value of k where we've got equal roots. So first thing I'd be saying is that b squared minus 4ac is equal to 0 for equal roots. Okay, and actually I'm going to run this in tandem with the question. Kx squared plus 3x take away 4 equals 0 has no real roots. I'm just going to do that next to it just to kind of show you the differences. Okay, so again, I'd be saying b squared minus 4ac is less than 0 for no real roots, right? So all we have to do is substitute in to begin with. So my b squared, that's going to be 3 squared, take away and get this in a bracket, 4 times k times negative 4. So that's 9 take away negative 16k is equal to 0. So I've got 9 plus 16k is equal to 0. So 16k is negative 9. So k is negative 9 over 16. Let's have a look at the marking scheme, see what we got for that. Yeah, you're getting a mark for using the discriminant, a mark for applying the condition, so the equal to 0, and then simplifying, and then your final answer. But just to show you the difference, I mean, actually, this one's probably not a great example because there wasn't the roots for this question. But say I got something where it was, less than 0 for no real roots. I'd be substituting in my equation, and maybe say I ended up with something like, x squared, I'll say plus 5x plus 4 is less than 0. Say you got something like that when you worked out. You would then be working out your roots and then saying, well, x squared plus 5x plus 4 is equal to 0. And I'm just going to make that really clear that this one was less than 0. Notice how the signs change there. Okay, and then you're saying, well, I need to factorise that. So x plus 4, x plus 1. So you know that x is equal to negative 4 and x is negative 1. And at that point, you would do your sketch. So this is the more standard question. The one we've just answered there is quite an easy one, really. So you're doing something like this, where you've got roots at negative 4, roots at negative 1. And where is this function less than 0? Well, it's less than 0 for all these numbers. So that's when x is less than negative 1 and it's greater than negative 4. Okay. Conversely, it would be if you were in this top region. So these are all the greater than 0 results. That would be when x is greater than negative 1 or when x is less than negative 4. Okay, let's put that down. That'll be less than 0. So just watch out for that. Sometimes this is a bit more common than this. Is a nice easy one for you. But my point is, when it's equal roots, you've got that equal 0 all the way. But when you've got the no real roots or the two real roots, you've got this inequality, this less than or greater than. But then you have to put the function equal to 0 so you can find the roots and then make a judgment on when it's less than or greater than 0. Okay, so this is the more common one. This is quite an easy one. So yeah, first question done. Nice. Hopefully, if that was you in the exam, feel nice and settled. And then I'd probably go on to question 10, do the polynomials or something.